All right then. So yesterday we have covered that the Apache Ambari services, that's for deployment and managing an Hadoop cluster over EC2 VM. And so we have basically checked that how to utilize Ambari servers, Ambari agent, that's for provisioning, managing, and for deploying the Hadoop clusters over cloud services, Amazon cloud services. Now, basically, we need to deep dive into the latest versions of HDP, because previously what we deployed, we have worked on the deployment of HDP version 2.0.6, but recently that what Hortonworks recently introduced the features of HDP 2.2 and the latest versions of Ambari, that is 1.7. So the version that has got to be released, and it has got a few more recent updates and new features that came up. So we need to know about that, and specifically it's been pretty important for the certification purposes, and also we need to know pretty much about the configurations on the services regarding utilizing Ambari and what is the latest features on Ambari that helps for latest capacity scheduler for the configs and updates on the Ambari dashboard. So let's look out. So typically, if we check for that, what we're going to discuss, basically, we have already gone through the introductions of Apache Ambari, and we have already gone through the Ambari innovation series. Basically, what we have discussed, and yesterday we have seen in the demo that Ambari versions 1.4, but I will also show today in the demo that the recent versions of Ambari 1.7, which has been utilized for provisioning of an HDP 2.2 cluster, and what are the steps for provisioning 2.2, what are the latest features that has been added into this edition of HDP platform 2.2 regarding configuration enhancement, versioning, and history, and also some of the features regarding Ambari administration, the views framework, Ambari stacks. So we need to go through that, and of course we'll go through the demos, right? So basically, if we just go through some recollection options regarding big data, Hadoop, and data center replatforming. So typically, Hadoop, a modern data center architecture that's for the big data and Hadoop, it's typically based on the replatforming visions of including big data and Hadoop, and they are typically depends on three major factors like business drivers, technical drivers, and financial drivers. So business drivers, which must be in the forms from reactive analytics to proactive interactions. So more or less using whenever we have been moving from the older generations of HDPs or Hadoop frameworks to the newer generations, we have been checking through that. It's all about like we have been moving from the reactive decisions to directly to the proactive interaction. So, and we have been gaining through more and more insights regarding that should gaining around the competitive advantages and optimal returns value. Technical drivers, like in the form, it helps for the data growing and movement exponentially, and it just also helps to move the existing systems overwhelmed. Predominantly what were just driven by the new types of data, so now it can easily inform into the analytics. So currently on the current versions of HDP platform, we can build very easily the analytics platform. Typically, if we check some of the ecosystem projects like Pig, Hive, HBase, Scope. So we will be easily seeing that on the HTTP platform. We have got an easy provision that for going through, for typically for going through the analytics side. Like whenever we have been written a Hive query using Hive QL, so after written the query, we'll be able to see that there's some option has been given that based on the query, automatically it would help to build up the corresponding analytics dashboard. So this all have been possible through the help of the technical drivers capability. Yes, is anyone having any question?
I think it's a no. I mean, right.
Okay, so would you guys please mute yourself if you don't have any question, because I'm getting some background noises. And another factor that's being majorly that's going to be factorize this platform replatforming feature, that's the financial drivers that regarding the cost of data systems architectures in terms of the percentage of the IT spend, the infrastructure cost. So and it will continues to grow over major data center investment. So the cost of advantages like the commodity hardwares and open source software, that also regards a major I mean, it's gonna to be a major factors that influences the financial drivers aspect. So there's basically an inequitable balance between the vendors and the customers in the market, and that affects the data center replatforming for big data and Hadoop. So similarly, if we check right now the corresponding Hadoop values, that the new types of data that's been coming out, and that's basically some of the data sources which are emerging into this platform, like Internet of Things. Typically, most of the Internet of Things sensors, typical normal the devices, the types of the data that we are getting, like unstructured logs or files, or some of the basic sensors data, typically from Arduino boards or Intel IoT dashboard, IoT devices, from Raspberry Pi devices. So typically those for the specific sensors data, it's pretty much important to identify the patterns for data streamings, and that could be automatically, that's to be helpful for whichever be coming out from the remote sensors or machines to identify those data. And that data, it's a very raw unstructured data which has been coming from typically from sensors. So to move those data into a predictable manner to the HDP cluster, it's very important to understand to handle those data and then move into the HDP cluster. So that's the factors that's to work with these types of the data. We need specifically a good valuable platform on this. Guys, could you please mute yourself? I'm getting sensible background noises. Similarly, those the other types of data like geographic data, server logs data, unstructured data, clickstream data, sentiments data. So these are all typically the raw source of data. Which would be valuable for to work with the new pretty new use cases for big data. So typically, right now the Hortonworks they have been working with tremendously with other their partners like Microsoft, Teradata, so and a lot of other telecom, healthcare. Uh, the corresponding the advertisement based history, and similarly few retailers based verticals. So they are having emerged a lot of sensors that the platform can work with all these new types of data, like whether it's a sentiment data coming out from a typical $1 million retailer based products websites, or if it is supposed to be a clickstream data that's coming out from an e-commerce based visitors data analysis, trails and optimize the website value typically for the retailer's value. Like typically for a retailer's analysis for big data, it's a very pretty important concept is that whenever they have been coming out for purchasing, the users are coming out for the retailer's website for purchasing the product. The pretty important point to consider is that what products the customers they have been choosing or they are being searching, and after searching those of the products, which of the products they are not choosing for the buying option. So they are abandoning the cart, the particular shopping cart for this option. So it is very important to understand those of the cart abandonment analysis. So using the clickstream data. So typically those of this analysis, those of the analytics that this types of analytics that's being also have been performed through HDP, and that's being they have been done in the recent HDP 2.2 platform. So it's all the typical Hadoop values that's been came up with this platform, and similarly like geographical data for working with the different matrices data values, like analyzing the geographic location based data to managing the operations that where exactly any geographical disruptions being happening. Similarly, server logs data. So typically, whenever people are performing the web log clickstream analytics or typical web log analytics, so it's pretty important to understand the nature of the log. So if it is coming to be a typical W3 SVC fresh logs that can be identified to diagnose the process failures or the security procedure, so the server logs analysis plays a very important role. And of course, coming to the social media analytics, like the unstructured data, that's whenever the people we started to work with Twitter data or Facebook data or LinkedIn data or any some of the social media data. So we have to people need to work a lot of the patterns in the files which being spread across the millions of web pages, emails, and documents. So unstructured data, that's a very typical common platform that's to work with. So all this, the new types of data, that's values of this platform, and that the current HDP platform has been enhanced to work with this particular types of data. Similarly, if we check that right now there has been a shift has been happened, as I said, from the reactive to the proactive interactions, like a shift in the advertising domain from mass branding to the targeting, from financial services that's happened from educated investing to automated algorithms, from a shift to healthcare, like from mass treatment to the designer medicine, retail verticals we have seen there is from static banding, people are moving towards a real-time personalization. So typically with the HDP and Hadoop, it allows the organization to use the data to shift the interactions from some post-transaction model to the pre-decision model, from a reactive to a proactive model. So it's typically pretty much important. So that's to understand that how this migration has been happening and how this platform leverages this flow of these interactions from the reactive to the proactive model. So there are some enterprise goals for this modern data architecture. So if we see that in this HDP data lake modern data lake platform, that typically the data sources which being affects this the model, the data systems and the applications. So typically it's based on the consolidated soil data sets, that's structured and unstructured data, and there should be a central data set that must be resided from a single cluster, but multiple workloads across they can work in the batch, interactive, and real-time mode. Typically, batch mode, like the processes, like if we could understand some ecosystem projects like Pig, Hive, all this ecosystem that's analytics-based platform, they all are batch-based um, uh, system. So they've all have been working in typical unstructured data but real time. And some of the platforms data that's being in the interactive manner. Some of the ecosystem projects like Storm, Kafka, which has been introduced very lately with the HDP platform 2.2, they are typically is a real time platform data. And also in the data systems, like from where this data has been typically has been imported or exported, like RDBMS, CRM, enterprise data warehouse, or typical ETL platforms. So the data has been tremendously in an interactive manner with those platforms as well. And typically in the application wide, we'd be able to see that the data, this reports has been utilized in typical business analytics, custom applications, and packaged application approaches. So there could be a central services that could be utilized for security, governance, and operations perspective. There could be a preserve this existing investment in the current tools and platforms, and there should be a single view of the customers, the product, and the supply chains for all the ecosystems in the modern data architecture. So typically, if we say how Yearn has helped us in this latest advancement, so Yearn typically transformed the Hadoop, and they have opened a new era for the entire Hadoop ecosystem. So Yearn is basically, as we said, I mean, it's a form-wise, it's a yet another resource negotiator, which is to be called as a new generations over the typical Hadoop cluster. So it's not only with the help of this architecture, it not only advances the platform for MapReduce, it advances the platforms for many other ecosystem projects. So Yearn is basically it's an architectural center for Hadoop, which provides a common data platforms across the many applications. It helps to support the multi-tenant accessing and processing, and Yearn could be utilized for batch, interactive, and real-time use cases. So it's not being confined to any of the typical use case model, like it could be utilized only for interactive-based use cases, or it could be utilized only for some of the predictive use cases. Yearn is a platform which could be utilized in any cases, and the HDP was a pioneer on this. So today we will be able to see that Yearn is typically working as a data operating systems as a cluster resource management on top of HDFS, which leverages the platforms like the other ecosystem projects like Pig, Hive, Cascading, HBase, Storm, Spark, all is being available to work on this platform through this help of this model. Similarly, if we see that how Pig is being able to interact with Yearn, Pig could be utilized to be work much faster. Pig queries we can run much faster. So as an admin job, basically our job is basically to identify that what are the process or what are the scripts that could be utilized to leverage the faster compatibility of Pig over the Yearn. So that could be a platform called Taze. So Taze is basically it's a we can say it's a framework which is leveraged on as an extension of Yearn, and it would be utilized for the faster capability for Pig. Similarly, Pig Hive could also work on Taze, so for the faster processing. Cascading, which is based Java and Scala based platform, so they could be also used to work much faster, and processing is could be much million times faster through the help of Taze. Similarly, there is a new platform came up for like this for NoSQL based ecosystems for HDP, like for HBase Accumulo. There is a platform has came up called Slider. Which works similarly like Taze. For Storm is typically is a real-time streaming-based data analytics platform, which helps to utilize the data to process the data in real time, but in streaming manner. So even Slider also works on Storm-based platforms over there. So Yearn also could be used to extend the Hadoop to the other data center leaders. Typically, as we said, like Yearn is an architectural center for Hadoop, so they could have a common data platform. They could be utilized for many applications. They could have support for multi-tenant access and processing. There could be a based on a batch, interactive, and real-time use cases, and it helps to support the third-party ISV tools. Like typically, with the help of HDP, not only we could work with it only HDP, but a lot of the tools that could be utilized for independent vendor specific like SAS, Actian, then several tools for machine learning, so that could be easily integrated with Yearn. With this current architecture. So typically all of these components in HDP 2.2 that's being called as Yearn ready applications, typically it just helps to facilitate the ongoing innovations and enterprise adoption. Like you'd be able to see like what are the other platforms apart from Pig, Hive, Cascading, HBase, Storm, Spark. They could be all Yearn ready through the help of the specific interrogative platform like Taze, Slider. But other than that, all the ecosystems, they are specific ISV engines. There could be also as Yearn ready. So they could be mentioned as Yearn ready solutions. So in the enterprise Hadoop, we'd be able to see there should be some of the central set of services which helps to enable the Apache Hadoop to be an enterprise data platform for the centralized services, like which could be utilized for governance, operations, and security purposes. So everything that plugs into the Hadoop that inherits typically these services, like if we see like in the governance model, they could be utilized for loading the data to manage and that according to this policy that has been utilized. And in the batch interactive and real-time data access, we'll be able to see that typically the modern data lake architecture. And in the security side, they could be utilized to provide the layered approaches to the security through the typical authentications, authorization, HTTP security credentials model, typically the accounting and data protection model. And in operation wise, typically a sysadmin approach, like to deploy effectively through Ambari web or Ambari portal, or to effectively manage the cluster, the entire platform. So everything that plugs into the Hadoop, this inheritance, it's got automated inheritance of these services. So HDP typically delivers an enterprise Hadoop. So if we see that in the modern data lake architectures that right now it's been working, so they work both in on premises and in cloud. So we have already seen that in the demo that how the HDP platform could be deployed, and it could be configured over the cloud platforms. Similarly, an HDP platform could be also interrogated. It could be also provisioned into a local on-premises environment, in a local cluster, in multi-node cluster environment, and You could leverage the solution in a typical VirtualBox background environment or in a Docker container. Typically, there could be some of the deployment choices, like we could be HDP platform. We could that could be also deployed into both Linux and Windows environment, both of them. Linux or Windows, both of the platforms, and the widest range of the deployment options that could be either it could be deployed in on-premises or it could be deployed in cloud. Similarly, here, as we know, that's an architectural center for HDP, so it is a common data set across all of the applications, and there could be a batch, interactive, and real-time workloads could be there. There should be a multi-tenant accesses, and the processing would be there. It also helps to provide a comprehensive enterprise capabilities like governance, security, operations, and it's also helps to load the broad ecosystem adoptions. Like ISVs can plug directly into the Hadoop whenever we need the pluggable modeling through any third parties ISVs. So in the operations of the HDP, we'd be able to see that operationalized approach, like for the provisioning, managing, and monitoring approach for through the HDP, that could be done through the Ambari and Zookeeper services. So typically, we'll be discussing more in depth about Ambari and the current versions of Ambari 1.7, and we'll be also able to see that what Ambari currently provides us for the not only for managing for deployment, but also for the configuration side. So let's see for a typical introductions on Apache Ambari. So typically on the Ambari, we have already seen that the Ambari dashboard, that how do you utilize to operate a Hadoop cluster. So as we say just in one word, Ambari is a framework to provision, manage, and monitor the Hadoop clusters. And what is the cell number? I didn't got the question. Whose cell number are you asking?
I thought it's Anil Anandita.
Oh, okay. So typically, in the Hadoop cluster, like in the dashboard, in the Ambari dashboard, we would be able to see and to monitor all the different resources in this dashboard through the summaries. We'd be able to see typically a summary page that could give us the details like this corresponding services name, the resource manager, the uptime details, the memory usage, the containers, applications, memory utilizations, and queues. Similarly, we'll be also able to get the typical configuration tab. That's where we could typically configure each and every services and the configuration matrices. So normally in Apache Ambari, if we could check over the themes right now that's being available in the current versions of Ambari, that's 1.7, that typically it operates on Hadoop at scale. Like it just used to deliver the core operational capabilities to provision, manage, and monitor the Hadoop clusters at scale, and it helps to integrate with the enterprise. Like it's a robust API for integrating with existing enterprise systems such as Teradata Viewpoints and Microsoft CSOM. You can integrate that with the enterprise directly with the HTTP platform. And Ambari also helps to extend beyond the ecosystem because it helps to provide an extensible platforms for enterprises, partners, and communities through the Ambari stacks and views. So we will check very quickly that what is the Ambari stacks and views. Um, So first of all, what's new in this current versions of Ambari package? They having introduced some of the core services in Ambari 1.7 like Resource Manager High Availability, Capacity Scheduler Refresh Queues, HDFS Rebalance. There is added versioning history for the service configurations. It has been also added like managing this environment.sh files, so we can typically managing those environment shell script files. There has been added an addition of a final tag on the config properties, and we could also be able to download the client config file. So we'll be checking in the hands-on side like what are those core services that's being added. Any of the client config files like hivesite.xml or hdfsite.xml, so those are the specific client config files we have been also being able to download directly from the clusters into the on-premises. Once we select the particular configurations, and if we want to download directly to get a tar.gz files from the configuration, so that's being possible in the from the current versions of Ambari. And this Ambari platform, it provides a typical Ambari administrations, Ambari views framework, Ambari blueprints, that's for the export configurations. And recently they have got that the advancement for Ambari that we could be able to deploy Hortonworks HDP platform through Ambari, not only through the CentOS or RHEL or Sales Plus platform, but also it has got the support for 1 to 12.04 precise environment. So we could be able to deploy HDP right now on 1 to 12.04 as well. And there could be some of the stacks being available for Ambari, like which has got support for HDP 2.2, and there has been also a stack advisor that's being available. So in this link you'd be able to find a list of enhancement. So if you just go through the link, you'll be able to find that a lot of resources that's being available on the current versions of Ambari 1.7. So what's new in this HDP 2.2, in this configuration enhancement? So they have been got introductions of some of the versionings and history like service config versions, which could be saved as per as the services. They have got introduced a list of the configuration history.
Ananta,
Yeah.
I have a question on the last slide.
Yeah.
What are the stacks you showed on the last slide? There is a section called stacks.
Sorry, what's your question?
There is a section called stacks, right? So could you let me know like what more about the stacks? What is the stack you are telling about?
Do you mean what is called stack advisor?
I mean, what are the stacks available? Like, what kind of stacks you are
That are available support for HDP to
Yeah. So I'll be coming in the coming slides. I'll be coming on that.
Oh, okay. Okay.
Yeah. So in the recent versions of HDP 2.2, they have been introduced the versioning, the comparison. Like we could be able to compare the different versions, and we could be able to filter out the changed properties and the revert changes, like any of the changes that which has been already made, but we could be able to revert those of the changes, that means make current changes. And there could be a beautiful the properties that could be available based on the audit logs of the changes. So recently in the HDP 2.2 platforms, more enhancement and more emphasis that has been given on the data lake infrastructure, that's for the configuration versionings and the history model. And also if we see that how this configuration history that you could be able to see, so could be they have added a new tab that's called config history, that could be consist of all the settings regarding the configurations like yarn, yarn default, new host, peak default, ganglia default, all the different ecosystem components that could have a specific configuration history. And they have been also added some of the filtering, sorting and searching approach, by which we could be able to filter or sort of the specific features for those of the specific configurations on the dashboard. And also you'll be able to see the history for those changes. Like suppose we have just made a change for the corresponding services, and in the next minute we have been after making the changes, we want to revert back those of the changes. So already we could be able to see those of the history for the changes in this config history tab. So that is the latest enhancement in HDP 2.2. And also they have added got the approaches for service configuration control. So like as we know that we could be able to filter out those of the change history. So in the filtering tab, if we could search over the what are the changes that's being done, or whatever the changed history versions, so if we could search over in this filtering search tab, so you could be able to get that. And also, if suppose any of the current changes, if we want to revert those of the previous versions, we could be easily do that by using make current, just by clicking on the make current tab. So all of this enhancement we could be able to see in this current Ambari that's coming out with HDP version 2.2. We could be also being able to compare the versions between earlier versions or old versions of the different platforms. So uh, the in the most recent versions like view, compare, or revert, if we want to check that in which date and time that the corresponding changes has been done, and who done that, in which particular authentications, which particular user permissions, so all the details that could be available under this comparing tab. So that's all this enhancement that has been done for the service configuration side. Also if we could see that what's new in this views framework for HTTP 2.2. So in the Ambari extension point, we could be able to see that there has been some of the enhancement has been done regarding Ambari web, Ambari server, and Ambari agent. So Ambari web is typically a JavaScript-based web portal that's being utilized to deploy all of the services, the core Hadoop services. And we have already discussed that what are the typical repositories for Ambari, and what are the typical, if we need to set up the a local repository for Ambari, so what are the components that you need to take care of, like Ambari HDP utils, local Linux repository, so all of those repositories that which you need to configure. But Ambari web is typically utilized for typical view that's by which we can typically see that how the Hadoop cluster is being running, what are the services is currently in running or in not running status, or which has been started, which has been not being started status, which has been failed, all of the statuses we would be able to see. Now also in backend when the Ambari server has been working, so in current versions of Ambari they have introduced a packaged interface on top of Ambari server that's called as tags. So what is the Ambari tags? Let's look at that. So for the Ambari views, as we said, like the view is typically the goal behind to create a good visualization for the view is to enable the delivery of the custom UI experiences in Ambari web, so that developers can extend the Ambari web interface. They could view, expose the custom UI features for Hadoop services. Ambari admins can also entitle views for the Ambari web users so that they could utilize this framework for controlling access for the views. So typically today from Ambari web portal itself, so user can be divided across based on the specific permission set, the related set of the their accessibility to the different services that could be provided. Like if for the admin, the user who has been logged in as an admin, so he would have all the accessibility for the clusters, core services, configuration history, versioning changes history, all of those services he could have the accesses. Similarly, if a user has been logging into typically a local user, so he might be have access to the typical some files. Similarly, if a user today he is trying to log in with the accessibility only with having through the HDFS and file system, so he or she that could have only the accessibility to only the HDFS local file system. So all the differences and this corresponding differentiability we'd be able to see in this current HDP 2.2, and we'll be seeing the hands-on also. So that is a typical part of Ambari views framework. So as you can see in this example view, this is called in left hand side, it's called a queue manager view. So in queue manager view, what you can see in typical engineering sections, like those of the different services which has been running, like suppose for example like yearn services, if that's one is running, so what are the capacity for a typical yearn cluster that's being running, engineering wise, how many cores are being in the running status, how many of them is not running status, what are the typical cases the monitoring has been done. accessibility, like administrators can create the ACLs on that or not. The jobs could be administrative jobs could be an ACL based or not, or it could be applied or not. So all these specific details that could be available in the queue manager's view. Similarly, if we could see in the jobs view sections for an EARN application or an EARN services, so you'd be able to see that how many map services that has been run for when running a typical job. And you'd be also able to see that beautiful tree-like architectures, like what are the different maps which has been run and their corresponding memory cores, the Hadoop clusters, the core services that has been run. And in the reducer side, you'll be able to see that what was the status for the reducer job, how much HDFS IOPs has been worked, what was the time, what was the operator's plan on that, what was the task has been run, what was the starting time, what was the ending time. So all the specific details that would be available for typical maps, task and reduce task. So this corresponding details that would be available in the job views. So that's all an integral part of the Ambari web and also the Ambari views. Next, that what we have talked about, that the view components. So typically this view that's being consist of, they serve as a client-side assets, like it's being based on the typical HTML JavaScript based portal. They also used to expose the server-side resources, such as they provide typically a REST-based endpoint so that the Ambari web that could be connected with Ambari server, that server-side resources with Java, and in the back, in the another side, it is being connected with Hadoops and other ecosystem. So all has been connected to, like Ambari web, Ambari servers, that's all have been connected through the simple REST-based endpoint. So there are several versions and instances also being available for this. Like whenever we just go and deploy the multiple versions and we need to create the multiple instances for the view, so we'd be able to see, like for a typical Ambari portal, for the views specific names, we'd be able to see the versions for the views, and we'd be able to see the corresponding instances. And based on that, we should be able to manage the accessibility and usage for those of the views. There could be some of the choices for the deployment model as well, like for Hadoop operators who are being typically interested for deployment of the views in an Ambari server, that's for managing the Hadoop clusters. Similarly, for the data workers who typically run the views in the standalone Ambari servers. So as an operator side, that's whose job is basically to manage the clusters that may have the views that should be deployed, like from the Ambari server, we could manage and deploy the views. The Hadoop cluster, the job is typically to store and process. So data workers on the another side, they could use those cluster and they can use a standalone Ambari server for the views. So we can also check, about more about the views framework from this GitHub links. So if you can check for the Ambari views, like blob, the trees, the examples, and also some of the development resources, like for the Ambari views, or the GitHub contributor page on the contributor views code. So you can get all this details over this link. So please go through that, all of this. Then comes through the stack advisor, which I was been talking about, that Ambari stack. So Ambari stack is typically, it defines a consistent stack with having a lifecycle interfaces defined, and that could be also extended. So typically the Ambari stack is a component that encapsulates the all of the different resources. Like it consists of the stack versions, the services, the components, dependencies, cardinality, configurations, commands. So all of the resources has been encapsulated together, and which could be having a stable lifecycle interface, and that could be also having extended along with the Ambari. So typically and dynamically, they could be add as stack plus services definitions. So if we could think of the Ambari server that's having an Ambari web interfaces, so the stack has been interconnected, and it is being integrated as a stack service definitions, and the stack alone, it is being encapsulated versions of the typical component services, like the versions, service, components, dependencies, configurations, commands, all has been componented together. So that is typically called an Ambari stack, which defines a consistent stack lifecycle interface. So the stacks are currently being in available status. So Hortonworks recently they have got introduced an operations ready a model which defines that the stacks are being actions, and you'll be able to see that they have already delivered 2-3 months back the ops ready model using on REST API on Ambari stacks. So to define that Ambari as a management for those provisioning, deployment, and for managing typically the Hadoop clusters over there. So you can check our details from their website. This ops ready operations model. And recently they have also introduced another certification model on this ops ready approaches. So it's typically is an administration job that's being accessed over there in that model, and it's being typically would be the focus would be based on the operations ready program. So it would be based on typically the Ambari views, tags, Ambari model for assessment over that certification exam. What is a stack advisor? So typically stack advisor that extends to the Ambari stacks to include also a stack advisor. It provides the recommendations for and the platforms on the validations on the component layouts and the specific configurations. It also helps to improve the stack pluggability, and it helps to expose us a new REST-based endpoints, like it's based on the validations on recommendations and typical the REST validations. These are the specific REST endpoints. They could be utilized during the cluster install wizards and for the configurations on the UI. So as we know that from the starting to beginning, from the Ambari, whenever we have been starting the deployment to the ending of the deployment, entire operations has been based on the cluster installations and configurations, all have been based on the REST-based endpoints. So Stack Advisor just helps to provide a recommendation model which could be utilized to perform the validations on this specific component layout and the configuration versioning section. And also the Stack Advisor typically they exposes to another REST endpoint. That one could be called the server name, then port number / recommendations, and another could be the server name, port number / validation. That are the two REST endpoints that would be based on the Stack Advisor. So Stack Advisor is it's typically is an extension of Ambari stacks. So let's have a very quick demo what on HDP 2.2 on Ambari stack. So what I'm using for the first demo is basically I've utilizing the HDP sandboxes, that's 2.2, and I'm running it through the VMware. So you can download this HDP sandbox 2.2 directly from Hortonworks website. I can give you the links to download. So over this link, you'll be able to find the HDP sandboxes. That is it's a packaged environment for integrating and working with HDP 2.2. So having all the latest features and functionality of the ecosystem project 2.2, and it's being also integrated with Ambari 1.7. So based on the versions of the VMwares and your OS edition, you could download the corresponding versions. Like if you plan to work on this HDP using VirtualBox, so you can download the VirtualBox editions, or if you are planning to work on VMware, so you can download the VMware edition. So After downloading this HDP sandboxes, what I did basically, I just ran the sandbox through VMware Workstation, and I'm right now into um, just on this sandbox here. What I did is after login into the sandbox, what I'm able to see that I'm able to get the IP address, basically the host IP for this sandbox VM, and I have utilized those IPs, and using the port number 8080 I'm able to get the Ambari deployment page. So what I'm trying to do in the first demo, that I'd be able to see that deploying, managing, and configuring the HDP with Ambari 1.7. So as you all know that Ambari is completely an open operational framework for provisioning, managing, and monitoring the Apache Hadoop clusters, and it's an initiative collections of the operational tools and set of APIs that could mask the complexity of Hadoop. Just helps to simplify the operations of cluster. So for this first demo, I have been using the Hortonworks sandbox. So let me log in. So the credentials are admin and admin. So after I'm logged in, I'm right now I can see the dashboard. So it's an unified view of the state of the cluster. So what I'm able to see right now, that's in this Ambari dashboard, I'm able to get all the, first of all, in the matrices tab, I'm able to see that all the default matrices like HDFS disk access, data nodes, number of data nodes in the live status, since it's a single node sandbox, so number of data nodes is 1. HDFS links, the memory usage, network usage, name node, CPU IO, name node heap, cluster loading, CPU usage, the name node uptime, HBase master heap details, supervisor services, all of the details I'll be able to get. If you check in the heat map, so you'd be able to see that what are the by specifying the selected matrices, like suppose in the host cluster, the amount of the disk space utilized by host or amount of memory space that has been utilized by host. So I'll be able to get a beautiful heat maps related to this particular usage. Similarly, for HDFS services, if I want to see that for this particular cluster, what are the HDFS bytes read that's being done, so I'll be able to see that those are the corresponding heat maps over there. So as you can see that in this corresponding sandboxes right now for HDFS byte rate, I don't have anything right now on this HDFS. I have not added any new files over there, so it's just a 0 megabytes over there. And also at the same time, including CPU, disk, and memory usage, I'll be able to see the various components here like app timeline server, data node, DRPC server, Falcon, Flume, Ganglia, Ganglia monitor, Ganglia server, HBase master, region server, history server, Hive Metastore, all the services that I'll be able to see. And there is another tab that's being available since it's an HDP version 2.2. That's the config history. So this was something that I was talking about, that they have worked a lot on this Ambari 1.7 to integrate and to enhance this config history tab section. So typically now if I would be able to make any notes over here for a typical services. So suppose I want to select a services called HDFS, and I want to configure a specific groups from here, and I can select any particular date. I could search over there like past 1 hour. Past 1 hour I didn't do anything, so I could check in last 2 days or in last 7 days the types of operations has been done, and based on the author. So if I could search over there, like whatever the operations that has been done, so I could be able to search over that. Similarly, another thing is that suppose if I select on services and I select on HDFS, So I would be drilled down directly to specify the service dashboard and configuration. So what I did, I just selected the service on HDFS, and right now I'm able to see that the summaries for the different services, summaries for different components for this HDFS, like the name node status, the secondary name node status, the data node status, the uptime for name node, that's from last 1 hour it's just being powered on, the name node heap memory utilizations, the data node status, like one data node is there, it's since a single node, it's in live, no node has still now has not been decommissioned, the disk usage for the nodes, the blocks, number of total blocks that's been running here, the block errors, total files and directories, and also in this alerts and health checks from the NAC US monitoring, I'll be able to see directly like whichever the name node or threads that's been running on, the processes it's been running on, and last checkpoint time, secondary name node processes, name node host CPU utilization, name node edit logs, there's all these informations that could be available. And there will be a beautiful service matrices dashboard that's being utilized here. That's like total space utilization, file operations, block status, HDFS IOs, then RPCs, which could show up the queue average wait time, garbage collections like the 100 milliseconds time that has been waiting for till the first generations, JVM memory status like the percentage of the non-memory non-heap memory utilization, non-heap memory committed, heap memory utilized. That could be visualized, and also it could be helps to visualize the JVM thread status. So typically for a typical services, the corresponding service details that's being available, if we, and we could easily drill down to the service each and every specific services dashboards and its configuration. And from here, from the service matrices page, we could directly move into the corresponding Ganglia pages. Also, let's see. We have been moving towards yarn. I've just selected yarn, and now I'll be able to see that in the summary section in the yarn app timeline server that the status of the service has been started, resource manager is being running, node manager is being running, yarn client also in the running status. Also in the simultaneously I'll be able to see that the corresponding the alerts and the health status checks for the yarn services, and there is only one queues are currently in running status for this yarn. What we'll do right now is basically we'll start to update the configurations for the yarn capacity scheduling policies. So what you need to do basically, so if we check right now resource manager UI for yarn, so here you'd be able to see directly that the default policy, the default HDP, the yarn, the typical Hadoop web portal, that's which could have all the default policies. So as you can see right now that there is no default policy has been configured for yarn, and no specific configurations being available from the cluster matrices. Now what you need to do is basically we need to configure those of the specific matrices for ourselves, and what you can do for this is go back to the yarn portal and come to the configs tab. So here we'll be able to see that what are the current status for the versionings and configurations that's being done on last. So in the resource manager page sections, we'll be able to see that the name of the resource manager for the cluster, resource manager Java heap size, the memory size that has been provided, if the yarn is ACL enabled or not, that information should be given, and yarn admin ACL information details, that ACL of who can be admins of the yarn clusters, that info that you could be added over there. So all this information has been provided over here. Now let us scroll to the scheduler.
Anil, what is
Hmm. Yeah, tell me.
I'm asking like, what is the full form of ACL? On ACL,
Access
anything?
control list. Okay, so in the scheduler, as you can see that here basically if you check in the capacity scheduler, so I'm right now in the scheduler node, and here I'll be able to see the yarn resource manager scheduler class, the scheduler minimum allocation allocated memory, maximum allocated memory, the node manager resources, CPU cores, since it's an 8 virtual cores that is being running, so it's being 8. Node manager for yarn, the resource percentage for the physical CPU limits, all the details that's being available over here. And also there is a section called capacity scheduler. So capacity scheduler that consists of the default properties right now that it's having for the default settings. So let's check out this scheduling policy. So if we just go to the again to the top of the pages, and if we could select right now the resource manager UI. So just come here. So under the nodes, we'll be able to see that in the what track, what is the status of the node address, the node HTTP status, and the health status reports, all the informations that could be available. And also if we go to the scheduler, so here we'll be able to see the application queues, that what are the default capacity was being utilized, what are the percentage that's being used, whatever has been over capacity utilized, and what is the maximum capacity was there. That's all the default settings has been done, and it's been given over here. Now, what you need to intend to do basically, let's change this capacity scheduling policy to where we just have the separate queues and policies for engineering, marketing, and support departments. So what you need to do is basically this scheduler capacity, the capacity scheduler properties. We just need to replace with the new properties, some of the new properties. So what I'm intending to do is basically I just need to change the properties. So for that, what I need to do, I need to copy and paste this new scheduler properties from here into this box. So I've just copy and pasted the above policy. That's that what I've showing here. This policy is am I audible?
Yes, Anandita.
Okay. So what I did basically, I just copied and pasted the new configuration policies from the in the capacity scheduler text box. That's in the capacity scheduler box for the yarn. And what I need to do is basically now I need to click on save. So when I click on save, I'd be prompted with a dialog box for the save the configuration with the notes. So I just give here the notes as changed capacity scheduler config, and now I can click on save.
Hey, good morning.
So at this point, it would prompt me that the configuration would be saved, but we still need to restart this affected components. So what I've been checking here, that it shows me a alerting prompt that some services configurations are not configured properly. We recommend that you should review and change the highlighted configurations value, or you still want to proceed with the correcting these configurations. So it just been prompting me for the yarn scheduler minimum allocations memory sizes. So its a default value has been given here is 250, but according to that the value less than recommended value, that's it could be default of 512. So it just been alerting me for this prompt for the yarn scheduler for the minimum allocations values from there. So what I could do is basically I can overwrite So now what I need to do, the configuration has been saved, and now we need to still restart the affected components. So we can see here there is an orange button has been came up to restart those of the services. So what I could do, I can check on restart and select restart all to start all the demos, to restart basically all of the demos by clicking restart all. So you will be able to see that all the background services, background operations which has been running, it would be starting and running over there.
Unusual. Yeah.
So just wait for the restart to complete, and then we'll be able to again checking the capacity scheduler policy for yarn.
in the meanwhile, I just have a quick question regarding EC2.
Mm-hmm.
So let's say after we install Ambari server on a EC2 and set up the cluster, and when we finish the work, like if we stop the nodes and after let's say after some time if we log again, so do we have to, so all the configurations will they be in place, or does it have to be like, do we need to do the setup again?
I'm sorry, your voice was breaking. What you said in the midway that if it is stopped and then?
Like as you know, to avoid from getting charged, we will stop the instances, and after we restart the instances, what are all the steps do we need to perform to get the server backup, the Ambari server, and also the cluster backup?
No, after stopping the VMs, so what it will do, it will just shut down the VMs. So your servers would get shut down. So everything would be configured. Whatever you have done, it would be there. So all you need to do, you need to just start off the services again. So your Ambari would be there. If you have provisioned already the Ambari servers, if you have provisioned configured the services already through Ambari, it would be there. Nothing would be left, or it would not be hampered. All you need to do is just after when you boot on the servers once again, after you have just being got the starting the new servers, you just need to check the services. If all of the services have already configured, like HDFS, Yarn, in the Ambari dashboard, you can directly go and you can check that if the services are running or not. If it is not running, so you just need to restart the services. That's all.
Okay, so
Same like Hadoop cluster. Yeah.
okay, so to get the Ambari dashboard, do we need to start the Ambari server start? Do we have
Yeah,
to?
Ambari server hyphen start.
Okay, so so it won't start automatically with the with the reboot of the server, right? So we need to.
It should be there default, but still you are just shutting down the VMs. So what you can check that if the Ambari servers is running or not. Most probably it is a process actually. So if it is in the started state, so by booting it would not be affected, but it should come up, right? Because normally what we do in the servers, we do not shut down the servers, but for the cloud, if it is needed for basically for paying purpose and all, so what you can do, you can check over this Ambari portals that it should be running. But if it is not running, what you can do, you can just execute the script that Ambari server start. That's all.
Okay.
But it should not be hampered. The Ambari server should be in the starting phase always. It's a process. Nothing than that.
Okay. Thank you.
Okay.
does it usually take this?
It doesn't take that much time. It takes maximums of 5 to 6 seconds maximum. So since a lot of services are being, it's just restarting. So that's why it might be taking that time. Um, Actually, in background, it's just restarting all of the components. Since it's taking time, it should not take. Okay, let me cancel this. Let me show you the another configuration, that's versioning configuration, what we call. So if we want to revert to, suppose we have been it is being v2, that's a version. Now if we want to move back to the version 1, so what you need to do is we just can select the version 1 on which versions we need to be back to, just to select those version, and we can click on make current. So if we just select on make current, in the confirmation dialog we just can enter that why you are trying to revert back in the section. So just can add reverting back and click on make current. So that it would configure, and we'll be able to see that there is a new version is being came up, that would be called as v3, which would be the current version. So see, we have just got a new version that's called v3. So what you need to do, you will just need to restart as before to ensure that this versioning just has got being affected. Sorry, should I have just cancelled this one? So what I need to do is basically I need to apply restart all, so that it could restart all of the components with the stale configurations, and we'll be able to see that all the configurations that we have been changed, it would be reverted back. Um, okay, let's cancel this for the time being, and let me show some other configuration change. Suppose if we want to compare the versions in the configurations, like there are suppose often the situations when it is difficult to figure out the difference between the two versions in the configuration. So suppose if we want to change the resource manager Java heap sizes, which has been mentioned here as 250 megabytes. Now we can change this in the settings page from 250 megabytes into 512 MB, and we can save the changes. So I can make a note of it, that what changes I have just done. Resource manager Java heap size changed. Click on save. So after that, I just go ahead and I could restart the services, so that all the changes would be reflected. So after that, on restarting of the services, if I just go ahead and check in the versioning icon that from here in the version services, that what the changes that has been done and which version I want to compare with earlier version. So in that cases we can compare those of the configuration changes from the previous version. So since for this sandbox, I am just making these changes for the first time. That's for this typical sandbox environment. So for restarting all the components, it might take a considerable amount of time for the first time. So as we can see that for the earlier components restarting options, also it has for the first time whenever it's just restarting the services, it takes a little bit significant amounts of time. So what I could do is that I could show up also the demo for extracting configurations for the edge nodes also, where we could be able to extract the configuration that's required to see the Hive client on the edge node from Ambari. So let me cancel out this operations. Let me go to Hive from the sidebar. And once I select the Hive, now I can switch to here to config tab in the service actions, and I'm already in config tab, so I just selected the service action. So here I'd be able to see that there's been giving a couple of options regarding to select the Hive client configurations or HCAT client configurations over so far. So what I am interested in here right now is to download the client configs file. So if I go to the download client config section, I'll be able to see that two options has been given to download the configs files for HCAT client and the Hive client. So what I could do is basically once I select the particular configurations, suppose if I'm interested to download the Hive client configuration file, so let me select. So this corresponding Hive client, that's the Hive environment.shell, Hive executive sh.properties, all this configuration client configs file in a tar.gz format, it would be downloaded. So we download this. And if I open this, so this is my Hive client configuration, that's star.gz folder. So what I can do is, if I could extract this one, so I'd be able to see that the Hive environment, that the corresponding extracted file that's having the Hive client configuration details, that's being available over here, like the Hive environment shell script, the executive log4j properties file, the Hive site.xml that's very specific to the Hortonworks sandboxes. So all this specific configuration file, the client configuration file, that's being available over here. So that was pretty much the steps that we need to do for configurations of configuring, managing, and deploying the data lake infrastructure for HDP 2.2. So in another demo, okay. In another demo, what I'm intended to show is basically the deployment of the HDP 2.2 cluster over a cloud VM. And typically it could say like it's a sandbox environment because since it's been running right now, it's in a 64 gigs server that's in a CentOS server, and it's been running typically a cloud-based VM. That's from Microsoft Azure. So I've just taken out a fresh VM from Azure environment, from cloud environment, and I just deployed Ambari using the same steps which I have just performed over yesterday. Now what I am intended to do here, basically it's right now the Ambari repo that I have utilized for this provisioning purpose is basically the current version, that's Ambari 1.7. So if I could show you. So if I could show you, that's the current Ambari repo. So its current version is 1.7.0. Subversion is 169, and so using this HDP Ambari repo, that's 1.7, I was being able to deploy the HDP cluster 2.2. Now here in HDP cluster 2.2, I have got the option that to directly log in as an admin, or to have to manage the cluster using as admin, Ambari admin itself. So default right now I have in this environment, I have just only one user, but of course I would be able to add the new user in user group management tab. This is being provided in the latest versions of Ambari. So there is one default user is right now, that's admin, which is typically the Ambari administrator. Now if I want to create any local user, so I'd be able to create the local user over here. Like suppose if I want to create a user that could be just for doing the local administrative jobs, like and I could be very specific about the authorization of those users regarding the specific resource utilizations, like he or she could be able to access only for the specific cluster, only for the specific services on the cluster. So I could be able to provide those of the specific details and informations for there. So suppose I've just I'm intended to create a user, a local user, and I could apply the status over there for those user, like active or inactive as an admin, and I could point that user as an Ambari admin or not. So for local user, generally you don't make the local users as admin, and also optionally I could provide a password for those for that. Sorry. For the local admin. So just given a simple password, and I could apply save, so that the credentials for the local user that has been saved, and this user would not have all the accessibility just like as admin the user could have. And also there is a tab called groups. So if you just come to the group, you'd be able to see that there should be a specific group related to the specific user. So here also, if I click on create local group, I'd be able to create a local group based on the specific set of the users, based on the specific permissions and authenticity for accessing the cluster resources. In the Views tab, you'd be able to see that the various successive views like jobs and the numbers of instances, the sliders, the corresponding numbers of instances. So right now, it's since a fresh Ambari portal is this fresh Ambari views is being applicable over here. So no cluster is being there. So what I'm intended to do is just I'm intended to deploy a cluster, HDP 2.2 cluster. So I'm just to go ahead and move over to the cluster deployment. So here, as you can see, after you just logged in, let me sign out and show you once again. So after you just logged in with your administrative credentials, so you'll be prompted to this page as welcome to Apache Ambari, the latest version, to provision a cluster, managing who can access the cluster and customize the views for Ambari users. So you can use basically the install wizard to select the services and for configurations of the cluster, and also at the same time you can manage the users and groups, and you can deploy the specific views for the view instances and granting of the permission. So if you just go ahead and launch install configuration, so you'll be go ahead with the first step, and you can name of your cluster, and you can click on next. You have got the advanced stack for the Hadoop clusters, like HDP 1.3, 2.0, 2.1, 2.2, and also you'll be able to get the advanced repository options. So since, as I said, like I have been interested to being working on the current versions of HDP 2.2. So for if you select the HDP 2.2, you'll be able to see that all the local mirror repository that's being available for this current platform. And as OS-wise, it's being available for not only for Red Hat 5 and 6, it's being available for cells and for Ubuntu Precise platforms as well. So on selecting this tag, I can click on next, and here specifically I need to provide the host name. So the host name of this cluster so let me select the private key file and give the host name. And I've given the username which I have utilized for during the provisioning of SSH passwordless SSH configuration. So I can click on next to choose of the services whichever I want to deploy. So since it's the current version, that's the HDP 2.2, so all the latest editions like HDFS 2.6, yarn MapReduce 2.6, TASE 0.5, TASE would be available also as a next generation Hadoop query processing framework on top of yarn, so it would be available. Nagios for monitoring and alerting purpose, so Nagios server 3.5 would be available. So it would be just like a same sandbox environment, a single cluster environment. Since single cluster in the sense because since I have just provided as a single node um, um, host name. So if I can provide the multiple VMs host name, so it would be just a multiple cluster configurations. So instead of sandbox, if you're interested to provision in the local environment like this or any specific cloud VMs like Rackspace or OpenStack VM, so you can just do that over here. So apart from Google Cloud Platform VMs, so all of the cloud-based VMs are in on-premises VMs. The steps would be similar that what I have just shown before that, and only in the Google Cloud Platform, the virtual in the VMs, the steps are pretty different, and we need to utilize a specific script from Google's cloud platform's script. And instead of directly go through the Ambari server, we need to utilize a utility called BD util. That's very specific to for the Google Cloud platforms. But rest of other than that, if you are using Rackspace, OpenStack, or Microsoft Azure, or AWS Cloud platforms, all the deployment steps that would be similar. Also, that's the components like Falcon, Storm, Flume, Slider, Nox, and Kafka. They would be also available. So Storm is typically a stream processing framework. It's a very real-time data processing framework, and Flume would be also available. It's a distributed services for collecting, aggregating, and moving the large amount of streaming data. So we can collect basically a real-time data with the help of this framework. Slider, as I just mentioned in the slides as well, it's a framework for deploying, managing, and monitoring services for distributed applications for year. Slider is typically working with Storm and Cumulo. Nox is a gateway. Just being helps to provide a single point of authentications to the Hadoop clusters, and Kafka is a distributed messaging system. So in a distributed environment for cloud platforms, typically we know for enterprise service bus configuration, enterprise ESB platforms, we should have the typical configurations like in the cases of Amazon Web Services in the cloud platform for distributed messaging system, they have a framework called Amazon Kinesis. It's a data pipelining and orchestration system. Similarly, for Hortonworks Hadoop platform, they have for this platform this framework that's called Kafka, but it is more distributed and it's an open source. So what I can go ahead to I've just selected all of the services I can select, and I can click on next. But in reality, basically you just could select based on your specific configurations, whichever the services you want to run. So Ambari is smart enough to assign the masters for in the specific nodes, like the name node configurations, history server, app time server, resource manager, Nagios server, Ganglia server, Hive Metastore, Web HCAT server, and Hive server 2, HBase master server, Uzi server, Zookeeper server, Falcon server, Nimbus, DRPC, Storm UI, Nox gateway, Kafka broker. So all these services that could be available. So since I have just utilized here a single host for this demo, so all of the services would be right now would be hosted in the single host here. But if I could utilize distributed host, so they would be deployed over the distributed host. Like master node services would be deployed in the master nodes, and slave services would be deployed and configured over the slave services. Just like in yesterday's demo, we have been able to see that for some of the all the master services was being running in the first three nodes. Rest of all the data services, data nodes, and clients that is being working in the rest of 4 nodes. So that's all would be automatically, it would be managed by Ambari. So after that, the step comes basically for assigning the slaves and the clients that what could be the slaves and client components in which host that could be able to run on. So host which has been assigned for the master components that could be showing with this star symbol. So since it's a single node, so all the masters and slave that will be running in the single node. So client will typically install here, as we know, HDFS client, MapReduce client, Yearn client, Taste client, HCAT clients, Hive, HBase, Peak, Scoop, Uzi client, Zookeeper client, Falcon client, and the slider one. And similarly, data node services will be running node manager, the master services for the worker services for Yearn that would be running, region server for HBase, the master services, the slave worker services for HBase that would be running, supervisor for Storm. Storm is basically the worker services for supervisor is basically the worker services for Storm, and the master services of Storm is called Nimbus. So all the what you can see here, basically all the slaves services that would be running also in the same VM. So that's why it's been prompting us. If we have multiple VMs or multiple hosts, more than one, so it would be automatically assigned that in which host it would be assigning the masters and which host it would be assigning the slaves and the client. Typically, client would be running in one of the nodes where all the slave services would be running. And the next steps is, of course, would be the customization. So here, first of all, as we have checked that it would be just show us some of the alerts that whichever the services that's being recommended for the customization. So what I could do, I could customize those services. And fourth one is Nox. So I can give a password for Nox master secret. So we'll be checking on Nox gateway in the next subsequent modules. So after we have configured on those, I can click on next. So before starting the deployment, we can just print out, take a printout of all the configurations that we are trying to do, and what are the packages, what are the repositories that are being utilized for these configurations for the deployment, what are the services that's been going and running, like HDFS, data node, name node, secondary name node, Yarn, MapReduce, app timeline server, node manager, resource manager, the taste client, the NAGUS server administrator, the Ganglia server, Hive, Metastorage, Hive server 2, Web HCAT server, database, HBase, that's a master and region server, Peak, basically for Peak clients, and Scoop clients, Uzi, that's a servers and database. So Uzi would be typically installed during installation time. We use a new fresh Derby instance. Zookeeper would be running in the Zookeeper server. Falcon would be also in the same. So for Storm, it could configure basically the master server, that's Nimbus, the slave server, that's a supervisor. There could be a UI server also, that's for Storm, where we could able to see the Storm configurations in the typically in the web console. And there could be a backend server that's been running for Storm, that's called DRPC server. It's not being available in open source Apache Storm framework. It's a very specific for Hortonworks Storm framework, the DRPC server. And also there could be a framework for Flume. The host slider would be also running, the Nox for the gateway purpose, and Kafka for broker. And if all the configurations and options being fine for the installation, so we can just go ahead with the deploy. So it would take a little bit of time for the deployment. So minimum memory recommendations that's for HTTP deployment is for if you're running for the standalone VM or suppose for the multiple VMs. So each and every VMs that should have at least of minimum 7 gigs of RAM would be there, and disk spaces that could be available from 40 gigs to 100 gigs of spaces is being recommended. So while if you are provisioning this VMs on cloud, so be careful that to select large instances. So if you are having any questions regarding today's session, let me know. So what we have covered so far for today, we have covered at most for HDP administrations and deployment over these 2 days. So we have been covering first of all the general Apache Ambari section, like what is Ambari, what are the sections for Ambari, why Ambari is so important for configurations. Like we have just gone through some of the steps for utilizing for deployment provisioning of HDP clusters over cloud, Amazon EC2 VMs, and we have also gone through the steps over the details for Ambari, like how the Ambari services has been running, what are the Ambari servers, and what is Ambari UI, and how they have been connected through the REST APIs. We have also gone through the steps for today, like what is the new features that's being available with Ambari 1.7 and HDP 2.2. We have gone through the terms like Ambari views, Ambari stacks, and Ambari stack servers, and also we have been just checking in this in today's demo, like we have gone through the background operations, like what are the how we can manage, deploy, and configure the various operations on HTTP through the Ambari dashboard. Like we have gone through demo on to specify on the service dashboard and configuration, specifically on EARN, like capacity scheduling policies, and we have gone through a demo on applying um, basically the versioning configuration history. Like if suppose for a typical services, for example, like in Yarn we have worked. Like in Yarn, if you want to create if you want to move from one version to another version, so how we can do that? So basically that specific configurations we did for versioning configurations using make current option. And also what we did is basically like comparing the versions of the different configurations. Like in Yarn we have also checked like if we change any specific value for the specific applications, like for we have changed just the value of resource manager Java heap size from 256 megabytes to 512 megabytes, and we have just changed the property from the Yarn settings, and we have just applied the changes over there. So after that, of course, once we make our changes, we need to restart all the services specific for those of the components that we make the changes. So since I made the changes for Yarn, so I just restarted all the components with the stale configs for Yarn. And also what we did, we also did extracting the configurations for the edge nodes. So I have just showed that how to select for specific services like Hive, just being checking up and downloading the specific client configuration file. Like I have just shown you like how from this current Ambari dashboard we are being able to download directly the specific client configuration file for Hive or HCAT client configuration, and we could be able to save it directly into our local system drive. And in another demo, what we did basically for installation and deployment of HDP 2.2, the latest platform, using Ambari 1.7 on CentOS Server 6.6 based on the Azure Cloud Platform VM. And the steps for the provisioning will be the same what we did for AWS Cloud. So almost the steps would be similar for all of the cloud platform. And what we need to be careful, basically just while we are provisioning through Ambari, just to be careful, like what are the steps that we are going to perform for the deployment. And we have also seen that there has been a lot of options that's been available from Ambari 1.7 in the latest repo, that we could be able to assign the users, local user, component specific user, service specific user, or there could be a default Ambari administrator which could have all this accessibility. And also we could be able to view the instances from the view tab, like specific deployment instances and all. So, and of course we could be able to create a local group based on the specific set of the users. So basically we have gone through the couple of demos for those, and so that's pretty much regarding today's section. And once the thing is left is that from the first module we need to cover typical HDFS commands like Hadoop FS commands and the web HDFS jobs. So we'll be covering those, and after that we could be starting the next module. That's next module, that's the interactive ecosystem. That's first we will go through the pig and this ecosystem project, and we could be covering up those modules, and then we'll be back once again, and we'll be covering in depth according to the certification guidelines, in name node high availability, HTTP security, several configurations on MapReduce and Yarn. All right. So let me know if you have any question regarding today, or then we can wrap up.
Thank you, Anand.
All right, guys. Thank you then.